Yes.
Marty says, check my speaker and continue without audio. Which ones?
Don't turn on the mic.
So continue without audio. Gotcha.
Yeah, because those are. it
I
gets
see.
entertaining.
Gotcha. I'll make sure.
Just go over, question 6.
Go over question 6.
Yeah, just as an informal discussion, how are office hours working?
Yeah. So as Mark asked, how are they going? Are the office hours working out for you guys? Are the times at a good time? Do you need to think about maybe switching days or a time? Are they productive when you guys have them?
Maybe a different time,
Maybe a different time?
because I have a class that ends at 5:45, so I don't get home.
I see.
until, like,
Okay.
My class ends at 7:15, so I have to come to like the end.
Okay.
Like this week I didn't have the class, so it worked out.
Right.
but
Okay.
Another day maybe.
Okay. Brandon, but does it work out for you? Are you still running the same kind? You got a class rate that ends right there?
No, it's a pretty convenient time for me. I
Okay.
finish work at 6 and I go right to the thing.
Okay. Yeah, how about you?
It's fine for me. I get out of class at like 3.
Okay, so for you guys, we can work out, like, we've got Michael that's helping out with office hours as well, so we can
So like the Tuesday.
do like a Tuesday kind of, so if we did it on
Same
Tuesday?
time.
Same time?
Yeah,
Okay, we can work around that.
But will there still be 2?
Yeah.
Or just 1?
There'll be 2,
Okay.
yeah, so we'll have we'll do like an office hour on Tuesday, we'll do an office hour on Wednesday for you guys. And then just let us know if you need help ahead of time, we'll send out like a notice, if you guys are gonna jump on it. Let us know, need some help. Cool. All right, good, all right, yeah.
Zoom is not a problem. You're okay with. How, just curious, when you meet with your economist, I'm assuming most of you are using Zoom. Yeah, in talking with them, I think that is easiest and most convenient for you. Do you want an opportunity to meet them physically? Cause one thing I've been thinking about is maybe inviting them to meet here on one Friday,
yeah.
cause the virtual world gets kind of impersonal. So
Are you guys
I'll
here?
invite them for lunch and I'll let you know that week so that you can carve out some time after class.
So are you guys, so who all is doing the internship as well? Okay, so is there an opportunity, Mark, to do that? I mean, do you guys come into the second floor and do that, or is that done remotely?
I do it remote.
Okay, gotcha, okay. I was thinking, if there's an opportunity there, maybe double up while you're in the office, but yeah, cool. Okay. So, today we're going to blow your guys' minds with a bunch of stuff. These are what I like to call kind of like a shepherd's pie of helper functions and tools and tricks that are really kind of necessary to get your projects going and to move into the visualization and the analysis portion of the material.
Where's
Share
Bank
my
Pages?
slides here.
You just type it.
You just toggle through, you get
That's not
How do you toggle
It's
through?
already in the doc.
control tab
Oh, control
It's
tab?
not-
or alt tab, sorry.
Yes, ma'am.
Bank Wages is not popping up for me.
Bank Wages, did you do the install ADR?
Yes. Let me just do it. Let me just run everything
You
again.
might have to check that.
Oh, okay, cool. So I have to keep doing the share screen thing. Okay.
Okay, I guess it's just not installing everything yet. Just what?
Brianna, are you, who had the problem?
Brianna?
Yeah, it was, I don't know, I ran the code, but I guess I just needed to do it again, because now it's installing everything.
Gotcha. Okay. Well, I'm gonna talk while you get that installed, should take a second. So the goals for today are to explore some data sets, different visualization, really just kind of understand what are the pros and cons of different types of plots. There are a lot that you can do, especially in R, specifically with ggplot. ggplot comes as part of, you can have it as its own standalone package, and for a long time it did, but with Tidyverse, it all got wrapped up together. So what makes that really nice is that you can do very professional looking charts and plots with your data in a way that is very seamless with the way that we've been manipulating our code, right? So up until now, we've been taking in data, right, as kind of our first line, and we've been piping in different mutate and summary operations to really kind of shape the data and it gets some real information out of it. We can add another pipe to that as well into a function called ggplot, and we begin to do some visualization around what it all exactly is that we are looking at. We're also going to go into dealing with dates, right? Dates are kind of an important thing in R. It is an object type. What makes dates unique is that R has a particular form that it likes to have dates in. That is probably not how you're going to get dates in on data. And so we need to have a way to take the data that we have and the dates and the formats that it's in, and then convert it into something that R can use so we can begin to do things like reporting and visualization. We're also going to cover just real briefly manipulating strings. So where this comes into play is with your projects. So it is often the case that we have information in a field that is very descriptive and we may only need one part of it, or the data is just plain dirty and we need to go ahead and clean that somehow, right? And we don't want to do that line by line. We just, there's probably just something important that we want to extract. And we can use R's built-in string manipulation software to be able to do that, or sorry, functions to be able to do that. And then we'll also briefly cover how to do some loops. Loops become important when we have very repetitive tasks. Think about loading data, right? You get a bunch of data files, you got like 100 of them, and they cover a bunch of different stuff. And rather than just sit there and load each individual file one by one, we can use loops to go ahead and loop over those operations, right? And make our lives just infinitely easier, right? And less prone to error. As a rule in this class, we like to let the computer do as much of the work as possible, for the sole reason that once we introduce ourselves, that's when the errors start to show up, right? Like, you know, mistyping stuff, or we didn't think about a particular case. Those when errors come in. And then also the data just changes. And so perhaps when we type something out, it was true then and the data changed and now it's no longer true. And we want to make sure that we're giving ourselves as much flexibility as possible to help remove some of those errors. So with that, we should have the bank wages data loaded. This is a real simple data set. You know, we've got 4 fields, I believe it is. Is that right? We've got 4 variables: job, education, gender, and minority. If we do a glimpse or an STR, what we can see is bank wages, right? We've got an ordinal, so we've got a categorical value, integers, right, for the years of education. And then we've got 2 factors, right? We've got gender and then the minority status, right? So if you remember from I think it was last week's lecture, we went over how to do some factors. Maybe it was a question before that. How to do factors, that's written showing as well. So these are strings that have been converted into factors. So when we print them out, they appear in a particular order. So why do we want to visualize? Can you guys take a guess besides reading the slides on the chart?
It makes it easier to interpret.
Easier to interpret? What else? It's easy to interpret, that's right. So you get some data, right? What are you looking at? Bunch of numbers? Well, plotting it, right, will help us get a better understanding of exactly what the data is that we've just been handed, right? So that can be for one of 2 reasons, right? One of which is you just want to get a handle on the data. You just want to see what you got, right? You don't know what you got, and so you want to take a look. The other thing is you want to make sure what you have is right, So if you've got some data and you know that, let's say, it's unemployment and you know that it should be falling over the time period that you're looking at, plot it and it's actually increasing, that's a problem. You know, you're able to kind of visualize really quick and get a handle on, okay, let me understand exactly what data do we have in front of us. But then we can also use it to kind of communicate our results, right? And this is where everything comes in with your projects, is that you know, they help us kind of clarify, they help draw attention to parts of the analysis that we want to draw the reader to, and it helps us kind of communicate the results that we're seeing. So you know, if you've got you know, you've run your analysis and you show that there's a relation between two variables, you can kind of easily go in and show that with a plot, illustrate it visually rather than just say, oh, here's a factor and it's negative, right? Okay, that's great. You've got a factor that's negative. What does that exactly mean? You can quickly and easily show that on a chart or in a plot. So you got bar charts, line graphs, and other visualizations. Can you give me some other examples of what a type of visualization would be besides a bar chart and line chart?
Pie chart.
Pie charts, very good. Can you do anything else?
A histogram?
Histograms, very good. Histograms.
Scatter plot.
Scatter plots, excellent. Scatter plots is very, very helpful. Anything else? You get clever, get creative. We're not gonna cover here, but you can also think about like GIS maps, right? So you've got you know, a map of, let's say, like the United States, and you want to have like a heat map, right, of population densities, right? You can also do like density plots, right? So you've got some random data, or you've got some draws from a sample, and you kind of want to show the distribution of it beyond a histogram. You can do density plots and things like that. R just really gives you a great way to kind of just carry out your analysis as deeply and as far as you want. So as you're going through your projects and you're going through the code, one thing you want to think of is like, okay, well, what is it exactly I'm trying to communicate with this chart, and what is the appropriate plot that I want to use, right, to show that. So as we kind of talked about a little bit earlier, you know, summary statistics just aren't enough. This is a really interesting data set. It's the Anscombe's Quartet. The Anscombe's Quartet was an exercise created back in the early 1970s where they have 4 data sets. They all have the exact same mean of X and Y. They have the same simple variance of X and Y. They generate the exact same linear regression line if we generate it. But when we plot it out, these look very different. These are not all the same. So if you just had a table that showed mean, variance, and you know, kind of some regression statistics, they would otherwise look identical, right? But it's clear here that they don't. We're just kind of using some Harry Potter stuff here to illustrate. My daughter's really into it right now, so I apologize. I'm taking her to Harry Potter World over Christmas, so I'm having to get all learned up. If you guys got any tips or good resources, I'm all ears. But yeah, so as we can see between, you know, Beauxbac, Durmstrang, Hogwarts, and St. Brutus's, right? These all look very different, right? And it wouldn't be until we actually plotted these things out and got a handle on what we're dealing with, we actually know what we're working with, right? If we're just going purely based on summary statistics alone, we wouldn't have any idea what's going on with it. And that's kind of a classic tip. You may have seen it too. Someone did a linear regression on a plot that looked like a dinosaur, right? And it turned out to be, you know, similar statistics as a regular kind of plot of data. You know, it becomes important to actually have a good sense of what it is that we're looking at. So where does this all fit in our current framework? You know, this really gets into the visualization, the interpretation and communication stages, right? Like this is where we get really iterative with our stuff. So we've generated some analysis. We've gone through the data scrubbing. We've done all the hard work with the coding, right? Now we're going to chuck it into ggplot, and we're going to see where the rubber meets the road, and you know, whether or not kind of the message that we've been building up in our head as we've gone through this data matches what we see visually, And then when we do see things visually, right, what other aspects of this analysis may be important for us to communicate to the reader? So we talked about ggplot and tidyverse package. ggplot is not the only one. There's many others. ggplot's great because it's specifically designed for printing out results. But there are others if you want to kind of go deep in the weeds on this, where if you want to create kind of some more dynamic stuff that you can kind of hover over and it pops up little hover over windows and things like that, you can just really go nuts with it. R is really flexible with that, and in a way that's not too intimidating. If you do ggplot, you can typically do a bunch of this other stuff. So with that, ggplot. ggplot is going to cover really kind of three basic things. Let's see if I can get a marker here. So the function today we're going to be using a lot is going to be called ggplot. Literally, it's going to be called ggplot. GG stands for Grammar of Graphics. That's where they get the GG from, in case you're wondering. It's not just something they made up. ggplot is going to take in, it's going to have really three key arguments. One is going to be the data. The next is going to be the mapping. And the last is going to be the geometry. There are a bunch of other arguments on top that we're going to get into a little bit today. And I think, if I'm not mistaken, when we did the first one, the first homework assignment, we did a basic line chart, I think it was, if I'm not mistaken. Is that right? Is it, Taylor, did you have like a bunch of like titles, and was that you, or is that the somebody kind of had clearly went into the documentation and added a bunch of nice ornamentation to their charts. There's a bunch of other stuff we can do here as well with titles, subtitles, captions. We can alter the size and the fonts of our text. We can add bolds, italics, change the placement of legends, colors, the whole thing. Like every aspect of a chart that you see displayed on the screen is editable. You can change, just like you can in, let's say, like Excel, right? But in a way that is consistent throughout the rest of your document, right? So if you've ever done Excel and you've kind of sat there painfully and try to line everything up exactly inside your document and get all the titles to sort of be in the right place, those days are over. ggplot's going to do that all for you. Just going to, actually, you're going to be spoiled by it a little bit. So for data, right? Data takes in a data frame. A mapping is going to be our X's and Y's. And it's also going to be other aspects of our chart that we want to have the data have an effect on, right? So, we want to make sure we give it an X and a Y, but what if we have categorical values and we want to have those color coded, right? We can add those two, things like colors. We can do things like line types, right? Line types are another one. Sizes, we can go all down the list, right? Depending on what it is that we're doing. Fills, things like that. And then geometries. So in R, the standard nomenclature is geom underscore and then the type. Right? So for instance, from homework 1, we did geom line, right? Is one that we did. For line charts, do geom bar for bar charts, geom point for scatter plots, et cetera, et cetera, et cetera. As always, we can go into the help with ggplot, and we can kind of just really go into the documentation on here. So we've got data mapping, and then kind of other factors that we want to, or other arguments we want to pass in. And then we've got our mappings here. So we can add aesthetic, what we call aesthetics. So aesthetics are what goes inside of the chart. And then we can add our geometries. There's a there's a way that you can add these things in to ggplot. So for instance, you can add your data up here with ggplot. And then you can go into your geometry and mess with your aesthetics, right? If you want to have the aesthetics specifically unique to this geometry, or you can add your aesthetics up here in ggplot if you want those to carry forward through all the geometries that you have in there. And so there's a bit of flexibility in terms of how you're going to do it, and that'll just really be based on you know, kind of what your data looks like when you're getting into your project. We'll touch on that a little bit here today, but really comes down to just doing some experimentation, right? So you kind of get ggplot running, you generate a plot. Does it look like what you want to? You kind of go and mess with it a little bit and try to get it to a form that's really appropriate for you. All right, over that. So went over the syntax a little bit, geom data mapping, and let's go over how to do some data here. So let's go into our scripts and let's start having fun here. It's over. So we got bank wages. Look at bank wages. Let's go ahead and start doing some plots. So we can do ggplot. Bank wages. All right, so let's hit enter there. And we're just given a blank screen, right? You can see our plot output down the bottom here. Right? Your plot output will always come to the bottom right-hand corner of your screen. Right? That's what we get. Blank. Well, now we gotta start adding stuff to it. All right. So let's go ahead and add, I think we're gonna add an aesthetic, right? So let's go ahead and add X equals education, right? And we can see down along the x-axis here, right, you should see a title show up, a label show up called education on the bottom here. And you should see some points plotted along here. So I think it goes from 0 to 20. Everyone get that so far? Good. Yes, ma'am.
So just for my notes purposes, aesthetic will help you like add titles.
Aesthetics are going to allow you to add elements inside the chart, right? So your aesthetics are going to be what you want to draw inside the chart. Right? So things like titles and labels, those will come in a little bit later separately, but for right now, the aesthetics are going to be, you know, pretty much strictly your like your X's, Y's, and colors. Things like that. So for this particular data, right, when we take a look at it, you can see it's a lot of categorical stuff, right? There's not really a whole lot of X's and Y's here. There's nothing really a Y axis we can plot against. We have a lot of counts, what we have, right? So these are individuals with their job titles and their years of education, years of education. So we can go in and do what would probably be appropriate, which is a histogram here. And we can do here. One.
What the bin width means.
So histograms, do you guys know what a histogram does?
Yes. Shows the frequency.
Frequencies, right. So how do we show those frequencies? We gotta pick bins, right? We gotta have a bin size. So what histogram does is it takes a bunch of data that has value to it, and it counts how many of that observation, right, fits that category. And what the bin width does is it allows you to determine the size of your category, right? So for instance, in this example, education has a value between, I believe, let's check, what is it? What's the range here?
It's grades, so isn't it?
I'm sorry,
Is it grades or number of years of?
years of education. So 12 is equivalent to high school, but then it goes up to, I think, 20, what's on? So it goes from 8 to 21, right? So the lowest level of education in this data set is 8th grade, and it goes all the way up to roughly master's. Assuming that they finish school in 4 years, right? Is that right? 12, no, PhD. Yes, it'd be a postgraduate, it'd be graduate school. And so by setting bin width equal to 1, right? What we're saying is that for each value, right? In that education variable, right? I want that to be its own bin. And then what the histogram will do is it will display the counts, the counts of every instance of that number, right? So for instance, we have a low value here of 8, and we've got 50-ish observations there of that particular number. And then we go up to, I'm guessing what is approximately high school or 12, where we have the most. We've got about 100, almost 200. And then we've got kind of something that's a bit more random, the higher we go, right? Yes, ma'am.
So if you put 2, it will be showing like the count for 8.
So the higher the number for the bin width that's right, then the bigger the bin, right? And so the less number of bins we're going to see displayed.
Why would you want to do that, Taylor?
We're talking about,
Like combine,
So, and you would combine it, so, oftentimes your data doesn't have as clean a structure as this does. And you'll go ahead and just run it, and maybe it just has a default of n equal to 1. I'm sure there's a default in there somewhere. And it's just too coarse, so everything gets kind of lumped into the one. So Brian, go ahead and put like bin equal to 18. Bin width
See
equal
what
to
the-
18 and show them what,
10. There we go.
you need to insert. I think
There we go.
Yeah, that will work.
So it did bin width equals 10, right?
Yeah, and see, and sometimes that's just what you get, and you're going, well, that's not very informative. So you kind of have to play around with that bin width to get it down to a level of resolution that's meaningful. Does it take like 0.5?
I don't think for this, because these are discrete. Yeah, it does, yeah. It goes
And
to-
so, is that any more meaningful than what we had earlier? Probably not. And so, but there is a point of going too small, right? So that's where you kind of just have to, this is where you run it once and then you come back to it and say, yeah, is that really the visualization that I want out of this? Yeah, see,
Yeah.
that would be very helpful.
We had 2. Right? Maybe that's a little bit more informative, right? So you've got a big
And
cluster.
that way you could clump it into, say, you know, pre-high school, post-high school, college.
Right.
After college, you know, postgraduate or graduate.
So it's usually, yeah, and where you see that happen a lot is when you have, you have a large set of data and you just got a ton of categories that you're cutting across, right? And they all have small amounts in them, except for maybe like 1 or 2 where there's just like a bunch of observations there. And so when you're plotting these things out, it just looks ugly. You just want to kind of cluster some of these together in a way that is a bit more meaningful. Maybe these values that are small kind of value observations, individually they're not very meaningful, but together they might mean something, right? So let's say you just had like a lot of people that had, you know, highest level of education at grade 8, and a bunch of like 9, 10, 11, 12, right? You may just want to cluster those together, right? Into something that's gonna high school and less, right? So you just wanna make them their own kind of thing. That's really where it becomes important. So, call. So, if you recall from our previous lectures about skewness, and we know we have that as a question in our homework. Why do you think the distribution is so lumpy? I know we've already gotten into this in a previous class. So let's go back to our data real quick. It's back to business equals one. Right. So why do we think this is lumpy?
I think it just varies, like some people just don't go all the way, some people do, there's different factors that play into how much level of education you get.
Mhm.
I think it's just like something that varies a lot.
Okay, perhaps. What about education in the United States? What do we know about it?
It's free up until, well, it can be free
Okay,
up until high school, but once you get to college, you need to pay.
and do they really try to get people through high school? Is that kind of a national policy, right? Pretty much, right? Like you're almost guaranteed to graduate. If you got a pulse, right, you're gonna graduate high school. So that's why we see this huge kind of spike here right around sort of grade 12, right? We're gonna see most people in the United States are gonna, at the very least, have a high school level education. Should they have a high school education? They'll graduate high school. Whether they have a high school level education is to be determined, but at the very least, some people, right, may not even make it that far. They'll get through middle school, and there may be reasons for that, like maybe economic reasons, and maybe kind of structural reasons for that. Right, but
So is the plot what you expected?
Yeah.
Okay, so it is what I would expect too. The part that makes me a little bit questioning the data is that lower mass down around 8. Can you I don't have an explanation for that. Why would it be 8 and say not 10? What? Are we saying that kids drop out of school when they finish middle school? That just seems a little odd. And so I would have to think a little bit harder about that to say, well, are those valid observations? And sure, in this case, it's bank wage data and there's not a lot of information, but I may go in and just filter by, education equal to 8, pull that up and see if those fields are meaningful for that particular group of workers in my data set. Because it could be that they just threw it in there because it was like, yeah, I don't have it's a missing observation, let's just call it 8.
or, right, it could just be not even missing, it could just be misentered data, right? So what do we know about the data set? Where is it coming from? Right, employees of a bank, right? Typically, when you think about employees of a bank, what do you think?
At least have to have a high school.
Do you think that at the very least, right, they'd have a high school level education, right? And so Mark kind of brings up a good point. And it's not a small amount either, right? There's a sizable amount of this employee data where they didn't even have a high school level of education, right? They dropped out in the 8th grade. And so one thing we can do is we can actually, use this kind of data now or use this plot to now go investigate what's going on inside of our data. So we can do something like bank wages. Filter. Let's say education equals 8. And let's view. It's all right. So what do we find? So we've got 53 observations. And we see that there are some custodial, right? So maybe custodial might make sense, right? That you would expect to see these. Would there be that many custodial positions open at a bank? I don't know. That seems like a lot of custodial, 53 out of 10% of this data file is comprised of custodial. I don't know, but there's a lot in here that are in admin, right? And so, as the analyst, right, and you see this data and you say, there's a lot that are in this A category, and there's a lot in here that are admin. Maybe that's a prompt for us to dig a little bit deeper and to find out exactly what's going on. What do they mean by administrative, right? And what are those people doing? And are these actual observations, right? Because it could be administrative in nature, right? But they're back office risk and they've got master's degrees, right? So they went through and did a couple extra years of school, and it's not really 8, it's something like 16, right? It's really their true level of education. Or maybe even 18 is a true level of education. So something we can dig into. Not with this data set, we don't have enough to go on here, but as you're going through your projects, these are the questions in your head that you should be thinking of. And we already went over the bin widths. So here we set bin widths to 10 using some sample data that we had from previous exercise, right? So breaking the data up into just sort of a number of bins and seeing the kind of granularity. So here we set bins to 10 on the left-hand side. On the right-hand side, we set bins to 100. And as kind of Mark said, right, like the more bins you have in your data, the finer grained it's going to be, right? Which may be important, but depending on your data, it could also really hurt the interpretability of your data, right? Between the left and the right, which one do you think is a bit more informative?
So how is this different than the command that Brian used? So in the header up there, it says this round bins equal to 100 versus bins equal to 10. Is that the command or the argument that Brian used in his text in his script? So there's a lot of different ways that you could go about doing it. Just kind of which way you think you can get to the most aesthetically clean thought that will give you the argument that you want to make.
So here we set bin width equal to 1. Here we set the actual number of bins. So something, right, set to 3, set to 5, set to 10.
In some ways, they're observation equivalent. It's just a matter of how you write it.
Yeah, I use them. We all kind of use them, I think, interchangeably. So it's an easy thing to overlook. Gonna add some comments here so we can keep track of ourselves. So you guys have any questions about histograms and move there? So we've already done line charts, did line charts on homework 1. What we can do is use the built-in economics data set in ggplot, right, to do an example with line charts here. So the function that we're going to, or the geometry we're going to use for this exercise is called geom line, geom underscore line, right? That's going to take in X and Y parameters. Right, so if we're gonna look at things over time, what's gonna be our X parameter?
Time.
Or like a date, right? A date. And then Y can be, since it's an economic data set, let's go and take a look at. So in this economics data set, right, we have date, and we have PCE, which is a measure of inflation, population, PSA, P-save rate, so personal savings rate, unemployed, and associated with UMP meds. Let's see, UMP med, median duration of unemployment, median duration of unemployment in weeks, and then unemployed, the number of employed in thousands, right? So employed in thousands, total population in thousands, and then we have PCE, which is a rate, or I'm sorry, personal consumer expenditures in billions of dollars, and we have the personal savings rate, which is 8%. What do you notice about this personal savings rate number? Is this in percent form or is this in the decimal form? The percent form. Right, so this is 12.6 is 12.6%. If we want it in decimal form, we would divide by.
How did you know it was in, how did you know it was in the percent?
We did we do question mark economics, right? So you see down here, we pull up our, gives us a little bit of detail of the US economics data set. So all of our inbuilt data sets we have with our functions, if we have any questions about what it is we're showing, we can always do question mark, enter the name of the data set, and it'll give us a little bit of a data dictionary about what we're looking at. So always important to kind of keep track of what we're reviewing to make sure that everything is on the exact same scale. So if let's say total population was in millions, but the unemployed was in thousands, right? Then that would we would want to make sure that we're on the same scale. Okay, good. So if we want to go ahead and plot the population over time, right? We're going to take in our data economics, and then we're going to use an aesthetic, right, to create X for our date, and we're going to use Y for our population, and then we're going to add it with geom_line. So every facet or feature in ggplot that we're gonna add is gonna be done with a plus sign. So it's gonna maybe a little confusing at first, right? So if you remember with pipes, right? When we pipe, we use that $ greater than, percent, $%. In ggplot, we're gonna use the plus sign. The plus sign is literally, we're going to add a new element to our chart, right? So we're gonna start with, let's see, let's go here, let's go to US population over time. Let's do plots. We're gonna start with our economics data set. Right. Now you can do things like mapping equals or data equals or things of that nature, but so long as you enter them in the order that they appear in the function, right? You can generally omit those, and we generally do, right? So you do ggplot economics, AES, X equals date, Y equals, remember population is pop. And now we want to add a geom_line. Right? So if you run it, let's go run it. You see something that looks like this on the bottom here. Right? So what do we see along the bottom? We've got dates going across, right? And ggplot is already formatted how that looks down there, right? So it puts in year breaks, right, for each year. We have the population kind of going across the y-axis, and then it's drawn our plot in the middle with population going up. One thing you'll notice is that it will automatically put in for the X and Y labels, right? The name of the variable that we're using, right? So, question. This is where we're gonna get fun. Let's play with this chart here for a little bit. Does this look like something you could show on a paper?
Rephrase it this way. Is this the way that you would see it represented in a textbook?
No, it isn't. Okay, so what do you see? Okay, what causes this for you to think whoever made this doesn't know what they're doing? What is this missing?
Like a title.
A title, right?
And it's just kind of like the values are too large for on the x-axis. It's kind of like
The value,
Yeah.
the x-axis or the y-axis?
why I mean yes,
Okay.
sorry.
Okay,
Like I would like make it not that many zeros.
okay, good. Now I'm asking these questions because Mark and I, every day, we have these usually Mark asking me, but we have these conversations all the
You
time.
wanna see an example? I have one that came up this morning.
No, we don't. No, you don't want to see that. I know which one you're talking about. Dude, trust me, I tell them.
Blow up your dashboard.
That's a thing of beauty, my friend. It's a work of art. It's a work of art.
It's a good example.
Yeah, let's pull it up. Let's pull it up.
Of what Brian does and how he's using our markdown.
Yeah, here we
I
go.
don't even think, I don't know, can you get to it from here?
Try. You can try. Dropbox.com. Maybe, perhaps, we'll see. Let's log in. Let's see, maybe I can. Here on my password.
You need your phone over here.
Oh, I got one right here. Oh, 2, 3, 7, 5. Wow, this actually worked. Okay, cool. All right.
It's right there. Just go to market reports.
Dude, the analysts are cackling in the back right now. I love it. Oh, yeah.
Just look at the top, you've already got it. Well, yeah. So these are done daily. And these are things that I look at daily. And this is all done by Brian in R using R and R Markdown. And
Yeah, so as you can see, so kind of like our slides in class, right? And maybe some of the things you guys have generated, right? This is all done dynamically on a server here, starting about, I don't know, 5 AM, I think, is when this thing kind of gets kicked off. And the first thing it does is it starts with a bunch of data, goes out and gathers it, and it does some analysis, and it draws some plots, which I then feed into our Markdown, just like you guys have been doing in your projects. And I've got a little template, right, an R Markdown template that I start with, and then I start adding plots to this document in our Markdown, which it'll then render as a PDF, just like you guys have been doing in your class. I've got a function that allows me to access Dropbox, and when it's done and hopefully ran without errors, it'll put that PDF in a Dropbox where, roughly 8:45 or so every morning, right? Everyone gets a little notification on desktop like ding, like, oh, there's a new document in Dropbox. So
so scroll down and.
how far down do you want me to scroll? I know which one.
Well, the one that has the issue in it.
Is that the density plot or?
No, just keep going, and I'll say when. When,
This one?
yeah.
Yeah, I know.
Okay, so blow it up a little bit, and then I want, okay. Let's just take the one in the upper left-hand corner. Okay, looking at that, do you see anything that's causing you concern?
The lines that I'm missing,
Yeah.
they're not connecting.
Yep, get some missing lines here, and then you also see
Okay.
some spikes, right?
Yeah, it's very volatile over
Yep.
there.
So, since about I don't know what those dashed lines, the vertical dashed lines are dates when the FOMC met. So since the last, not the current one, but the previous, since the last FOMC, not the one this week, but the one in July, something screwy is happening.
Yep.
And those are, just things that you just kind of have a refined eye to look at tables or charts or plots, and you just learn over time. So if you go back to what Brian has in the R script, compare what you see here, total, just the total picture compared to what he has in the script. And let's start letting Brian do his magic, which is all the attributes and aesthetics that you can add in a ggplot.
Yep.
That are really nice and clean.
Now, in this particular case, this is a good example. This is something that did get picked up early. It's being driven by the data. It's a peculiarity of the data, but Mark is right. When we see this, right, like that, it's an obvious one, right? Like there's an issue with the data here, right? Something weird is going on. So this is a case where we would want to go ahead and investigate.
So you created this with R.
It's all in R. So I use
Neither slides and all.
so this is a heat map that we generate using the Geom Heat, I think is the name of or Geom Heat Map. These are Geom lines that I'm just drawing to create some densities. These are what are called facet wraps, right? So let's say you've got categories, right? You've got a bunch of lines, right? And you don't want to show them all in the same chart. You want to break them up into individual charts, right? But they all share a similar feature. They share similar dates, right? Or they share similar y-axes, right? But you want to show them separately because maybe there's something different going on with one of them that you just really want to call out, right? So you can use what's called a facet wrap or a facet grid to break out your data by some sort of a category, whether it's a date or whether it's a factor or what have you. Did I go on? Yeah, this is a Geom bar, right? We just did these a second ago, right? So these are just probabilities that we run. What's another cool one we have in here? Is a Geom bar applied with some data about the size of the Fed's balance sheet, right? So we've added a Geom bar and a Geom line, so you can add multiple geometries into the same chart. So you're not just limited to doing just a bar chart or just a line chart or just whatever. Here we've got a bar chart here showing these kind of balance levels. And then I want to have just a single line that shows what the total is, right? Over the entire set, because as you can see, right, like, okay, so I've got data that's going down, right? I've got some negative data here, but also some positive data up here, right? So if I want to know what the total is, the total between the two where it nets out, visually, I wouldn't really be able to see that too well, right? So we want to add a line here, right? That does that for us. So the reader doesn't have to think too hard when they look at this. It's important to kind of break things up by category sometimes. But we also we want to be mindful of what the total is. We don't lose perspective of what the entire data set is telling us, right? What else do you notice about these? We've got what's a
Go back and apply it
Yep.
No, go, yeah,
Yeah, we'll go back to our code.
or show, no. the R script and so you can look at that and say, ooh, yeah, that's,
Kind of ugly.
maybe that's okay for, analyzing your data and getting a quick, gut check on things. But it's clearly not what you would want to put in your final report.
That's right. That's right. So we call it a couple things, right? One of which is, this doesn't look that pretty. The numbers perhaps aren't very informative going on the y-axis. What do we notice about the labels here, right? Is this pretty informative? Like, do we know what this 1970, 1980, 1990, do we have a pretty good idea what that is? Right. Yeah, we know those are years, right? Pretty confident those are years. What about pop?
No.
No, not at all, right? So maybe the first thing we want to do is change that pop, right? Into something a bit more informative. We can do that with labs, right? So labs allows us to change the different titles, right, that are in our chart. So so in labs, let's go and see what labs can do. Labs. We can do title, subtitle, caption, right? We can also do X's and Y's, right? And that will allow us to be a bit more informative. So let's see, maybe Y is, do you think we need to have a label on the Y-axis?
Yes.
Think we do? Okay. Do we like the way it looks with the lowercase t, or do we wanna?
I think capital.
Okay.
I thought it was-
What about the X?
You said that X.
Is it X, A, and Y?
Oh, sorry. Gotcha. So Y is population, right?
I would put population in thousands, just because you would change the numbers.
Maybe population thousand. So let's go to economics. Is there anything in here that tells us about our data necessarily? It just says month of data calculation. So what range of dates does this cover? Do we know?
None.
How do we find that?
Range.
Range, very good. It's range. Right, so what do we get? So 1967 through 2015. So July 1967 through April of 2015. Okay. So what else do we think is going to be important about how we're going to label this
A title,
title? So we want to call it
population.
whose population?
Think.
Oh,
Not that
No,
one.
there's nothing.
The economic,
No.
okay.
So which let's go here.
What, when, where?
United States population.
Yeah.
Bingo, US population, okay. Is that a title? Right, US population. Is this daily, what type of
Over time.
observations are these?
Time series.
Are they daily, are they quarterly?
Quarter.
Quarterly, okay. Okay, so, do you have anything else about this? Yes. Monthly. US monthly population. Let's add we can do a subtitle. Subtitles are nice because the title of the chart tells us the type of data series, right, that we're dealing with. What the subtitle can tell us is something about the data, something kind of unique about the data, and especially something that might change, right? So this chart is always going to show US population, right? But perhaps, we only want to show a particular date range in the data, right? Or the data is going to update, right? So this thing's going to kind of be its own living thing. And we can use the subtitle to capture some of that. So we use subtitle equals Y 1967 to April 15. Now, where did this data come from? Looking at the little help file here.
Fred.
Fred, very good,
St. Louis.
very good. Excellent, so we can use caption to give source attribution in our charts, right? So one of the big things in research, right, is making sure that we're properly attributing the source of the information or data. If it's your own calculations, right, you put down author's calculations. If you're using data from somebody, right, or you're bringing it in from some outside source, you always want to make sure that you're giving proper attribution for it. One of which is, just kind of it's the ethical thing to do. If you're using somebody else's data, you want to make sure that you have the appropriate permissions to it and you're giving them the proper attribution. But then too, for the reader, if they find your research compelling and they want to use it, they want to know where to get the data themselves, right? Or if they have questions about the validity of your data, you want to give them the opportunity to be able to go look and see for themselves what the data actually is, and without giving some sort of an attribution, that's not something you can do. On top of it, it helps build trust, right? So it's not just, you're not just pulling data out of thin air or making it out of whole cloth. Like, no, this is in fact coming from one of the most respected economic research databases on the planet, Tim Fred. So we've added date labels. We've got axis labels, we've got titles, subtitles, and caption. Let's go ahead and run, see what this does. Look at that. So we got US monthly population, right? July 1967 to April 2015, population in thousands, right? Got the dates across the bottom, right?
So, one thing I don't like about, do the zeros tell you anything?
No.
Those just kind of get in the way, right?
Right.
So I would scale things such that I would get rid of
So
that and then change the units of measurement. Does that make sense? Because those zeros are just getting in the way.
exactly. So there's two ways we can do that. You can either do it in the data itself, right? Which can get a little dicey, right? Be a little risky, because what if you're now changing the scale of something in your data, and what if the rest of your analysis depends upon it? If it is just purely aesthetic, right? You just don't want to show them any zeros, or it's not informative. You can change it directly in your aesthetic. You can do numeric, kind of arithmetic, right? Inside of this aesthetic. So with population, we want to maybe change it to millions instead of thousands, so we can just divide by 1,000. But whenever you change something in here, right, and you've got a label, let's make sure that it's reflected everywhere else in your charts. That way, everybody knows what you're dealing with, right? So instead of thousands, we want to put down millions. That's right. How's that look?
Better.
Look better?
Yeah.
Okay, awesome. There's other little things we can do as well. One thing I like to do, some people have opinions about it, some people don't, right? See how this is kind of this gray base got.
So how come you put it to millions if the original number is that, like, this is 275,000?
So that's right, so it's 275,000 thousands, right? So we're gonna add, so if you add 3 zeros to the end of it, you get 275 million, right? So we're just kind of working the other way, right?
That's, Taylor, your question is exactly why you don't need those zeros,
Yeah.
which is confusing,
Exactly.
because you're looking at thousands on thousands.
Oh, like in the
Yeah.
original data set, the
Yeah.
thousands are in thousands.
Exactly,
Okay.
exactly, yeah, so that, exactly. Yes, yeah,
I think I might be doing something wrong because my plot's not coming up. I just see the old plot.
see what you got.
Like I have this.
Oh, put a plus after GM line.
Oh, here?
Yep.
Okay,
There you go.
okay, thank you.
Lovely, lovely. Yes, ma'am.
Is there a coding that you can use to make the text bold?
Yep.
Like the titles?
Yes, you can. We're gonna, we're actually gonna get into that right now. So this looks better than what we had before. A lot better. It's informative. This is something you can actually start reporting to somebody, right? Maybe not necessarily put in a final research report, but it's gonna get you talking, right? For one, there's this background area right here, right? This is all grayed out. Some people like it, some people don't. I don't. I like clean backgrounds for my plots. So one thing that I almost always do, I mean, almost always do, is something called theme BW. And what theme BW is, that's theme black and white, right? So that, what that does is it sets up this chart area that we have here, and it will set it up as a, all the background elements in a black and white format, right? So you get that very stark, kind of bold, almost Excel-like, right, kind of presentation. So I run that, it gets rid of all that grayed out background, right? So I now have something that's a bit cleaner to look at. I don't have that gray area kind of messing around stuff. I still get the grid lines and you know, you can mess with those. Those are kind of nice to have. I usually leave those in because they give you a visual anchor, so you're not just trying to draw with your finger or your eye, trying to figure out what this data point means. But theme BW is something that I typically like to do. Now about bolds. So if you do, I could teach a whole class just on this one next section alone, so I'm just gonna go over just a couple right now. I encourage you to do question mark theme and look to see all the different things that you can edit here. This goes on for a while. It's still going. It's still going. There you go. And you see dot, there's more. There's still more after that. You can do things like legend sizes, legend locations, text sizes, fonts. You can do all different types of colors and things like that in your charts, depending on what standardization of format you're using, which you know, may be a thing in where you're working or where you're doing your work. Some you know, some places have a standard kind of aesthetic that they want for their charts. So I'm in the middle of a project now at the Treasury, and they have a very specific chart template that they use, and it has to conform to that style. Their style has very specific colors. You know, if your firm has a very specific color palette, right? You want to be able to go and make sure you can choose those. For these projects, where you know it's a little less so than that. But the things you're typically going to end up working with, right? So you're going to start off by typing. Yes, ma'am.
What if you wanted your title like you want to censor it?
Yes, we'll get in that in a second. So let's do. Okay.
See how it says axis title X bottom or axis Y left, right?
So let's do that. So
Maybe that's the axes, I'm sorry, but those are for your axes label. But
equals. So when you're dealing with themes, where it gets a little crazy and you're gonna spend a lot of time Googling because it's just a lot of different things you can play around with. You're typically gonna have either what's called an element text or an element rect, or an element rectangle, right? So either the things you're gonna change inside your chart are gonna be text, right? Or they're going to be shapes that are inside of your plot. So with the title, right, we're gonna probably change the text. So do an element text. Right. So if you want to do a bold, right? Right, face equals bold. And I guess it's a bold title. If I want to center it, I'm going to screw this up. I did it. You can use HJust.
Did you know they were 0.5?
Okay, can I be honest with you? I've done this a couple of times. Usually my titles are long enough. For me personally, I like my stuff left adjusted. And that's sort of what our defaults do. If I ever have to move it to the center or to the right, I end up having to Google it. And so I've had to Google this a couple times. And so I knew it was HJust, and I'm pretty sure it was 0.5. So if I do HJust equals a 1, that's going to right adjust it. Right.
0 is.
And it'll default to HJust 0, right? And I'll bring it all over to the left. So depending on where you want this thing. Now, what type of parameter is this? Is this a category or a number?
Category.
It's got a decimal point, right? So it could be any value between 0 and 1. So if I put in 0.25, right? Didn't go all the way over to the center. So depending on what value you put in this HJust, it can be from 0 all the way over to the left, 1 all the way over to the right, and then everything in between. Right? Depending again what the particular style guide or what particular formatting, right, might be required to do. For your work, it's largely just aesthetic, right? Like typically you have things centered or you have things sort of adjusted over to one side or the other. You're not going to really place it around in between, but this is something you could do. Right? You could, in theory, put it somewhere. So let's go ahead and just keep it at 0.5 right now, and that's the title. What do we see here? What's wrong now?
The subtitle kind of looks a little,
Subtitle, right?
yeah,
Subtitle looks a little wonky.
yeah, it just doesn't go with the flow.
That's right. Okay, so you can change the subtitles with plot subtitle. Elements. Text. So what do you want to do with this now?
Also,
Align.
So you very least you want to bring it in line with the title above, right? It's up to you if you want to bold your subtitles. Typically, as part of my own kind of, we don't have really a department style guide necessarily, especially for some of the work that I do with the daily reports, because that's just something I generate. So my own personal style guide is to bold the title and leave the subtitles unbolded, or even unbolded in a smaller font, right? I even reduce the font size. That's up to you. That's totally up to you. So if I do that, right, now I have them both in the middle, right? Actually, let's go ahead for the caption source.
Why don't you find a good breaking point We're 90 minutes in.
Let's do one
What's
more.
easiest?
Let's do one more. So we did bolding, we moved it around the chart, right? What about the size? Right? So let's say I want to increase the size of my plot title. And so the size equals, let's say, 15. Okay. So inside of here, right, I can adjust the size of my text with size. And they work just like font sizes do in Word, right? You've got a 10 point, 15 point, 20 point, whatever. We can adjust the face, right? By bolding it, right? And we use HJust, right, to change the location across the top, right? And those all take they can go between 0 and 1. Right, so 0.5 is gonna put you right in center. There's a bunch of stuff you can do in here. You can change your access labels. You can change all the fonts that are associated with everything you see on here. If you have legends, you can change where the position of the legends are gonna render. If you want them on the bottom, the left, the right, if you want them inside, where inside you want them, you can do all that. Again, if you go through the themes help file, and then if you find yourself getting stuck, you just don't know even where to begin, doing a Google, right, will immediately take you probably to Stack Overflow, where there is a very lengthy conversation on how to do all of this. And the first response is typically the best one. Yeah, we're 90 minutes in, so why don't we go and take a break? You guys have any questions?
Yeah.
Yes, ma'am.
Not appropriate.
Something else?
No.
Okay, cool. But, what do you say, Mark? 10 minutes, 2 minutes?
Yeah, and
10 minutes, so let's come back at
go 10:45.
10:45.
I didn't get that. Could you try?
Sorry, it must be part of the class too. Very good. All right, so let's come back at 10:45 and we'll get into the second half of the class.
Report in the presentation that we do on the updates.
Okay.
So to answer your question about breaking up your R Markdown files into like smaller chunks, right? And then knitting them all together as one. What you can do is in your main R Markdown file, with a code chunk here, you know, you use R and like echo equals true. Well, if instead we did R child equals, and then we name a file that we have in our directory, an R Markdown file in our directory, whatever is in this R Markdown file will get knitted and automatically appended to the document. So for instance, this is our main R Markdown file. I'm gonna call this in class example, we've got our date and everything in here. Now I've got a second R Markdown file that I have the plot that we just did a moment ago, right? I've given a little kind of heading title called US monthly population. We've done all of our bolds and adjusts and labels and everything else, right? We're gonna clean up our chart. And now what we're gonna do is I'm gonna show you that when we knit this, right? The PDF that we get is gonna look exactly like it would if we just had a code chunk underneath that had all that stuff in it, right? So we're gonna knit. This thing. And here you go. Got our heading, US monthly population, the code chunk that we want to display, and the chart underneath, right? And you can do this for as many things as you have, right? So what's nice about this method, I think Taylor was running into this was, right, you've got a lot of stuff you're trying to knit. You've got this gigantic markdown file and it's easy to get lost in them. And it may make more sense to break it up, right, into separate R Markdown files and just kind of scoop them all together and have them all knit as one document when you're ready to go, right? Because one thing you don't want to have happen is that you finish one section of your project or you finish one section of your homework and, right, now you're working on the next and this thing is just ungodly huge. And, right, because your paging back and forth in this document, you run the risk of potentially, fat fingering an error, or like, putting in some kind of character in there, or making a change to the code that you didn't want to make changes to. So you can use this inside of this code chunk where you have the R, but child equals and the name of the file, right, that you want to append to this document. And that will allow you to break your stuff up.
So, would you put this like in order of how you want it?
Yeah, I'll
It
have
has
to
to be
in order.
ordered,
In order. It'll-
because
Yeah.
otherwise it will, the way it orders there is the way it orders out. So
Okay.
you definitely wanna have like answer 1, answer 2, or section 1, section 2 when you get to the project.
Okay.
Did you create that R markdown?
Yeah, just like,
Did you
yeah,
show it to them?
Yeah.
Okay.
that's what we're looking at. Yeah.
Your
so-
grades are visible now, by the way.
Oh, thanks.
Sorry about
Yeah, that's really important.
that. So that's how we handle that. Actually, since we're here, let's hit this class. Okay, so we've gone through a bunch of stuff, just to recap. We've drawn a line chart, we've changed what the background looks like with theme BW. We have added some elements to it by changing the text size, by bolding, add labels, captions, subtitles. We've taken something that was very basic and plain when we first started out, and we've made it into a very descriptive, pretty much ready for publish chart here, right? Pretty much good to go. And this is with a specifically a line chart. Where's my slides? I'm sure I'm missing it here. So one thing I do want to go over is, one thing is kind of nice and powerful with this, are doing scatter plots, right? So if you're just doing a lot of time series stuff, you may not run into an awful lot, but if you're not doing a lot of time series stuff, or you've got categories that you want to show the relationships between two variables, you can use the geom point. Let's do scatter plots. And what do we want to do? Let's do unemployment and PSA to VERB. Unemployed versus P save RT, personal savings rate. Okay, so we're gonna start with ggplot. Comics. We're gonna add an aesthetic, right? So for X, we're gonna use unemployed. Y equals piece RT, right? So if I just have this, what are we gonna draw? If I stop my code here, what are we gonna draw?
A regular graph with unemployment.
Is there gonna be anything on the inside?
No,
Why not?
it's in lines.
You're right, we're not gonna have anything inside, because we haven't added geometry yet, right? We haven't added geometry yet. So if I just ran this, right, I just get a blank, I just, my axis would have some stuff on it, but I haven't added geometry yet, so there's nothing in the middle. So to add geometry, to do a scatter, we're gonna do geom point. If I do that, I get a nice scatter plot of our data. So along the x's, we've got unemployment. On the y's, we've got PSA vert. In the middle, right, we show as dots, right, all of the observations that are a part of our data. That's about right. And then we can do, there we go, geom smooth. So one thing that's nice to show is to add what is basically a linear regression line, right? On our data, right? And what that's gonna do is gonna tell us what the sort of fitted line between all these points is going to be, right? What it's also gonna give us beyond that is some descriptive statistics visually, right? By means of an error bar, right? So, and it's gonna show that as a shaded region. So when we fit things like, you fit lines with linear regressions, these are statistical functions. Statistical functions have things like standard deviations, right? How much uncertainty is there in this data? And we can visually represent that, right? Through shaded regions on the side, which geom smooth is gonna take care of for us. Show that here. Okay. So here's our fitted line. Geom smooth.
Do you delete geom point?
No.
We'll keep geom point.
Do you think,
Straight.
do you think give it the linear regression?
Should I could do it for us
And see
anyways.
the method at the bottom?
Yeah, method was. New one. There we go.
Is that LM?
So let's go into our function real quick. So that was a new one for me too, because in the past,
It didn't default to that.
yeah, it didn't default that. So let's go to geom smooth. This is the fun part about doing these things live.
I don't know, that AB line is what I would use.
Oh, really? You use smooth. You use AB line, you use smooth. So geom smooth, right? Creates a fitted line. And it defaults to, what does it say? Method equals no. It doesn't say what it defaults to. It's chosen based on the size of the largest group across all panels. It is used for less than 1,000 observations otherwise. Okay. So there's a bunch of different methods that you can use, right, to fit these lines. Again, these are statistical operations. So in the output, it told us that we're using this function LOESS, which is like a linear regression with like a loss function. It's going to give you a much more, like a curved line fit, basically, right? It's going to fit a curved line in your data, right? That's going to give you the best fit based on the data. In this particular case, though, we really want just a straight line, right? And so we can use method equals LM. LM is R's internal function for running linear regression. So we're going to get that later in the semester. I think towards the middle end of module 2, I think. We may touch on that a little bit. If you want to run a linear regression, you use the LM function. You can call it directly inside of this geom smooth. What does AB line do? Let's see what AB line does.
You have to put in the regression. Y on X, Y tilde. Thing.
Let's find out. We use AB line.
That done with, it just basically runs the regression and plots the regression.
Let's see now. Here we go. The GMAB line did not do much of this. Wonder what it is. Oh. How do you usually call it inside your function?
I can't.
Can't remember?
Yeah, but I just know that's the AB line in plot, I know how. I don't know, I don't use it often in GG plot.
Gotcha. 'Cause I thought the, for GMAB line, yeah, because I think you'd specify the parameters inside the AB line function.
No, AB line does the regression and gives you back A is the intercept, B is the slope.
Gotcha, gotcha. Comments, all our hard work here. There we go. And here we go. Using Geom Smooth, a fitted line to our data. So what do you notice about this fitted line in the shaded regions? Let's clean this up a little bit so we can see it a little bit better. Because this gray background is really throwing me off. Fortunately, I know a function that can clean that for me. There we go. That's a little bit nicer to look at. So what do we know? What do you notice about the shaded region on this line? It's subtle, but there is something kind of unique about it.
It's kind of like slanted a little, like
Right.
it's a little
Yeah.
wider-ish.
Right.
The highlighted, like
Mhm.
the shade around the line
Mhm.
kind of goes like,
It's not constant.
yeah, it's wide.
Right.
and
Right.
And then it gets a little skinny.
So where does it get wider?
Towards the end,
Okay, it's wider towards the end, it gets narrower towards the middle. So what do you notice about the data?
It's condensed in the middle.
Right, there's not a whole lot out here. There's not a whole lot out here. There's a lot in the middle here, right? So this sort of shaded region corresponds a little bit to what's going on in our data. What do we notice about the line?
It's not like,
The
You-
blue line itself.
yeah, it's not like showing like it's like a strong correlation.
Okay,
It's kind of just more so like a kind of weak negative type
Okay.
of thing.
okay. So what do we know about personal savings rate on the side here? What unit is this? This is in this is dollars, is this? So this is in percent, right?
Oh.
So this 10 over here corresponds to 10%, 5%, 15%. And then the unemployment corresponds to numbers, right? So as, what do we see about, what does that line tell you? What can you infer from that line about this data? Or the relationship between unemployment, the number of employed persons, and the personal savings rate?
as,
You were gonna-
as unemployment starts to increase, personal savings decreases.
Okay, and so as unemployment goes up, personal savings decreases. Why would we, does that kind of jive with your economic intuition? Why is that?
Because if someone is not employed, they can't save as much as someone is.
Sorry, not making any money, you got no money to save. You're gonna be blowing through your savings, right? So that makes sense. Okay.
What would it tell you about the overall economy's behavior?
Overall, the labor market is kind of bad because.
So
more-
when the overall economy is bad or the labor market is bad, what would you tell me about the level of savings?
Well, people are spending more because they're not saving.
You wouldn't have as much savings. You wouldn't have like saved as much.
So are people more likely to save when the economy is doing well as opposed to when it's doing poorly?
You're more likely to see when it's not doing well, or like, well, never mind, it could go either way, the way I'm
What is
thinking
it,
about
what
it,
is that telling you?
it's telling me that they're not saving,
When the economy is.
yeah, when the economy is.
When the economy's doing poorly, right, they're not saving. When the economy's doing better, they are saving.
Yeah.
So if you heard, if you didn't have anything here, and you heard that the personal savings rate was beginning to fall, right? What would you begin to infer about unemployment?
If it wasn't those numbers,
No, so this is what, so we have some data. We've run our analysis, we see there's a negative relationship between personal savings rate and the level of unemployment, which kind of makes sense. Now, we're given a new piece of information, right? And a new piece of information is that the personal savings rate has fallen from 10% to 7.5%, right? That's the only data point we have. Knowing that, what would you expect to see happen with the unemployment level?
it would decrease.
The unemployment would,
Decline.
so personal savings rate is beginning to fall. You expect to see what happen in labor? Unemployment would
I think it would go up.
Oh,
Go
the
up.
unemployment would decrease.
go up, yep, there you go, unemployment would go up, that's right. Similarly, if you heard that unemployment's dropping like a rock, right? Everyone's hired. Right, that's the only data point you have, right? The amount of unemployed people in the economy is shrinking. Labor market's red hot, what would you expect to see out of the personal savings rate?
Increase.
Go up.
Go up, that's right.
Does that data go
That's 2015,
it doesn't go through?
the crisis or the COVID, yeah, it doesn't go that far.
Another thing that you could see possibly is that this is from 67 to 2015. If you did it for, say, 2020 to today, I don't know if you'd see that relationship.
Okay, I am going to do something that I probably shouldn't, but
Yeah,
Mark raises a good,
He's going where I wouldn't go.
I'm doing it, here we go, we're doing it live.
Doing it live.
Okay, this is gonna lead into the dates, right? So we're gonna transition out into dates. So, R has a bunch of different, data types. We've got strings or characters, we've got numerics, right? We've got integers, booleans, true, falses. We also have a data type called date. And what date does is it actually contains a value, right, that corresponds to the date. So when we plot things out in charts, and we have, let's say, March 5th or April 6th, that when they plot actually in the correct order, right? That the dates go in a certain order. Now, where it gets a little confusing is, so how does R do that? It actually stores it as an integer value. So it stores an integer value indexed based on the number of days since 1970. I'm sorry, number of seconds since January 1st, 1970, right? So if I were to take date, now it is to, as numeric and a particular date, it would return an integer value, and an integer value would correspond to the number of seconds since January 1st, 1970. So if you ever see something in your data where you think you're using a date and you're getting back a bunch of numbers that clearly aren't dates, probably where your error is coming up. It's R for some reason it's trying to convert your date type into a numeric. Now there are a bunch of different types of ways that we can represent dates. The way that R does it is in the year, month, day. That's the standard R format that it wants to use. So for instance, if I wanted to do something like as dates, Yeah, if I want to say what says it says it's 22nd, so 2023, 0923. I return that, it gives me 2023, 0923. If I enter this in as say like a standard, kind of like an American style date representation, so they do like 9/22. And then walks. So I tried to do that, right? I'm gonna get an error. Right? So the format that R wants to work in is this year, date, month, day. And when you enter in your dates in kind of a standard R format, you're gonna put them inside of quotation marks. You won't put them in as just sort of as a plain text. Does that make sense? So this is what R wants, right? R is specifically looking for this. R wants. This is what R wants. So all of your date fields have to be in that particular type of format.
Since you're gonna share that with them, you should just type it out like you did above it, standard R format, or maybe that,
That's fair enough.
I think you've got it there.
So what do we do if we have R in, I'm sorry, what if we have a date in one of these other forms, right? So you can enter in dates in like a bunch of different ways, and you're gonna see this in your data as well. Right, you can have this. Right, so date types. Right, so we can do month, day, year, or it could be 9/22, 3, right? I could have let's say yeah, so month, day, year, right? So you have like September 22nd, 3, or what you may see in some of your files are things like 2023 M9, right? Or you may just see you know, sept 2023, something like that, right? You're gonna see a bunch of these different types of formats for how your data comes in or how your data is coming in. The Lubriday package does a really good job of parsing through a lot of these things for you in a way that makes handling these dates a lot less painful. So just to give you an example, right, let's say I have a date type that is say 2023 and 9, right? I can use the function, it comes in couple different ways. I can do MDY, right? So month, day, year. I can do YMD, year, month, date, right? And what those will do is that they will look at what that string is, right? And it will automatically parse that string and convert it for you into a format that R can then use to do things like plots and whatever. So in this particular case, right, I've got the year first, right? So 2023. And then I've got the month next, so M9. That's how they kind of classify this. So if I did, say YMD, and then do I have days in here? So I can do truncated equals 1, right? So I'm not gonna use that day field, right? So what do we got? 2023, it's on the bottom, 2023-0901. Right? So I took something that was non-standard and we converted it into a date. Yes, ma'am.
So what does the as date function do again?
So as date will force a string
Yeah.
into a date form. So when you do like as date, you're forcing something into a date type. Just like you did like as numeric, you would force something into a number type, or as character, you force it as.
You pull up the help page on that, because and remember, this is why Lubridate is really helpful. Because instead of going to as date, you use Lubridate
Yeah,
to move everything from a string into a date,
that's right.
which is much more flexible than as.date. For the reasons that Brian showed earlier, where you have to have it always in that format that's found up there, the year dash month dash year, day. Lubridate is like, okay, I'm gonna take pretty much anything you can tell me with regards to a date and put it into the way that R likes it.
That's right. Yeah, so in the help file, like, so R really wants something in a pretty standard format. And it gets ugly because you end up dealing with a bunch of different formats, if you have things that are non-standard, and R can go in and, Lubridate can use its own internal machinery to do these conversions for you, which is very, very helpful. What if you now wanted to print out something that was good, just.
So, do you use this like if you have dates in your data set that you want to convert to the R?
Yeah. Yeah, so different,
See, because if you try to plot things and the dates aren't right,
it's gonna be garbage.
it's a nightmare.
Yeah. And
The worst thing about R is dates.
So if you're getting in data from a source online, sometimes you'll be lucky and it'll show up as like a date, right? And you can easily quickly convert that, no problem. A lot of researchers use the M9 convention to stand for like the month, so M1 through 12. That's not something R can natively handle very easily. And so rather than having to figure out like with a bunch of cases and whatever, right, you can just easily use YMD or MDY to go in and convert that to something R can use, right? Another neat function that you can use is called makeDate, right? So let's go ahead and open up makeDate real quick. What makeDate does is it can take in these individual components of the date, right, separately, and then spit out a date for you. So for instance, if I have a data file that has the year, the month, and the day, right, separately listed as individual, let's go build dates. So you make dates. So I had year equals, say 2023, month equals 9, and day equals 2, right? So I've got these individual components here separately in my data. When I run that, right, it gives me a date, right? A fully built date. So I didn't have to do any pasting or anything like that, right? I could just in makeDate, take in those 3 different components and then spit out, right, a data itself. And then lastly, if I want to do some kind of formatting on my dates, right? So let's say I have this in here. So I'm gonna do I'm gonna just copy this up here. So. Let's do. No, that doesn't look very pretty. That doesn't look pretty at all. And what I can do now with format is spit the output here as something else. So if, for instance, I wanted to do, let's say,
Slash, use the slash.
we do like the slash, right? So I can do month, day. Here. So now it says 9/1/23. Right? So here is just 2023-09-01, right? If you're just trying to quickly parse something, that may make sense, but you know, what if people are used to this convention here, or what if you're working with somebody and this is the form that the date needs to go in, you can quickly make those conversions. You can also do other things as well. You can do something like right. You can actually print out September 1st, 2023 at the bottom, right? So with this format, right, you can adjust your format. Now, there's one thing to be very careful of here when you're using this format function. This format no longer prints out a date, right? So it converts your date into a string that is a little bit more aesthetically appealing to print out, let's say, as a chart title or a chart something. Good question, yeah?
Yes. So if we use those functions, does that just change one date or like all the dates in our data set?
All the dates you use. Right, so if you have so let's say you have a variable in your data set called date, right? And it's showing up as one of these forms, right? Let's say that all the dates in
Why
your
don't
data
you
set.
create a list and do that?
Yeah, sure. So create a date list. So I've got 3 dates in here, 23/1, 23/5, and 23/12.
And those are strings. It
These are
doesn't
strings,
say they're
right?
dates.
These are
It is
strings.
not.
So it's a character, shows up as a character. It's not a date yet, it's a character. So I can do Y, one. Right, and that spits out
Okay.
like the formatted dates. Check that real quick. Right, and those are now date types.
So you just need to know the format of what's in that date list or string. And then just give it the looper date.
Now, one thing that's nice about converting it to dates, right, is you can now do math on them. Some basic Boolean operators like, are they equal to each other? Are they greater than? Are they less than, right? You can begin to do filtering. So for instance, I've got 2 dates. Now I got 2 different dates, date 1 and date 2. If I want to check if date 1 is greater than date 2, that's going to return a true. So date 1 is greater than date 2. So date 1, right, is in 2023. date two is in 2022, right? So date one is greater than date one is after date two. So if you want to do things like filter your data set or kind of partition them out, right? You now have the ability to, right, do those things using the, you know, with your date field as a date type. Does that make sense? So let's go and see that in action. Let's go and take our
My text is green and I don't know why.
your text is green, you don't know why. Where's your text?
It's in the console, not console, it's in the script.
What's that?
You probably got a let's see. Green?
Yeah.
Green? Yeah, it's commented. Why is it commented?
Yeah, I don't, it's not, it's.
Can you run it? Oh, you forgot to end your quote up top here.
Okay.
Yep. Yeah, if you see a lot of green like that in your codes, if it's not commented out, it's probably because you didn't end the quote and it's treating everything like a quote. So let's go ahead and.
Where's the? It's still not changing.
So let's take economics, right? Let's go ahead and do add new groups with take. Let's do pre. Send.
Is that?
So you see what we did here?
Did that say I false?
If else,
Oh,
if else, sorry. So I've got my economics data. And I want to break, so kind of what Mark was talking about earlier, so we've got this long period of time in our data, right? This huge period of time in our data, maybe something changed somewhere in the data, right? And we want to see exactly what's going on, right? So arbitrarily, we're just gonna pick up a year, it's 2009, seems like a good year to pick. And what I want to have is a new category called pre-2009, where it flags it as pre-2009 if the date is before 2009, and it's 2009 and current, right, for everything else. So if I run this, right, I should get what I saw before, right, which is just simply the data, right? That doesn't really tell me anything. But you know, the color aesthetic. Of that new category that we just created. What that's going to do is it is now going to color the data points based on whether they are in pre-2009 or 2009 current.
And that ggplot will do that for any categorical.
Yeah, do that for any category. And you see, what do we have now over here? Do you notice what we have over here? Right, we've got a legend here now, where the title, right, corresponds to this pre-2009, and we get the values on the inside. And actually, what's nice about it is that it created two new fits to our data, right? Based on the groups that we have. So I got one for pre-2009, I've got one for 2009 current. So kind of get at Mark's question, right? Have things changed over time, right? Is there a different set of behavior now than there was at some point earlier in the data set? Perhaps. Does that make sense? So what we've done is we've used this these dates, right? We've been able to filter based on the dates because they're now in a date form. And then we can feed that back into ggplot now, right, as a category. And we can allow the colors of the data points to change based on the value of that category. So if the category is 2009 current, it'll show up as red points. If it comes before 2009, it'll show up as the blue or turquoise, or we want to call that color. That's what we call it. That good? Cool. Cool. All right. That's dates. So kind of as a public service announcement as you're going through projects, if you're going to run into issues with errors in your code and things aren't plotting correctly and it looks really wonky, generally speaking, the dates are just in a really weird format, and either they're not being imported correctly when you're loading your data files, or if you thought you were converting them somehow, right, that they're just not being converted correctly. Right. So for instance, if you thought your data was in month, day, year, but it was so it was in month, day, year as we would write it, but let's say the data comes from Europe. In Europe, they use the day, then the month, then the year, right? Not feeding in the correct kind of formula, it can cause a lot of issues, right? It can show as being very, very, very. Okay. This is literally like year one of being an analyst with that right here. Like just this one section is like, that's like the biggest pain point I think for a lot of folks. Let's see.
We had date problems yesterday.
Yeah, dude, you always have data problems. So what'll happen is that you'll have your data, you'll plot it out, and your lines just go, they just do weird stuff, like, okay, that's not right, that's not right at all. But you're looking at your data, it's just NAs everywhere, it's like just garbage dates, like 2023, or like 2033 or something like that.
4,000.
Yeah, like just weird, or it's just, or you go to plot it out and you look at your x-axis, and it's just a bunch of integers going out to very large values, like that's also not right at all, like this is all totally wrong. All right, so if you want a little conversion key for dates, when you're doing your formats, I use capital B, this is the unabbreviated month, right? If you do lowercase b, it's abbreviated month. Go nuts, go wild, right? Art does a pretty good job of with that formatting your dates. All right, that, Aaron, organizable, yep, do those, make dates. And we did a bunch of in-class stuff, we're there. Formatting, again. Manipulating strings, Christ, okay, we don't have a lot of time. So for manipulating strings, there is a package called Stringer, right? So Stringer, if you just will allow you to do a lot of really nice manipulations with your data, right? If you need to do things like remove blocks of of text from a field, or if you need to extract very specific things out of a field, right? So, for instance, if I have, let's say, an example field of, let's see now, let's say I have a field and it is, states. Okay. Let's say in every single observation in that data frame, the states start with state colon space, right? And then the 2-digit state code. Do I want to print all that out when I'm printing? Probably not. Do I want to come up with a bunch of case whens that are going to parse a statement of 50 case whens that are going to treat these things, to convert all these things? Probably not. That's just going to be a horrific waste of time. What I can do is I can use str remove, right, state. So I feed in my state, my input, and then I can put in a pattern, right? And that pattern is what I want that function to look for. And when it sees it, remove it from that string. So I want to get rid of state in the space. And all I want to have left is that state code GA. It did exactly that. See what we did there?
So you just removed the space between,
No, it actually removed all this text. So what it did is it looked for this. It looked for this exact string or this exact sequence of characters, right? In the string we passed in. And when it found it, it removed it. Right. We can also use things like str detect. What str detect will do is it will look for, right, this pattern that we have in here. So it's going to look for this exact string, and if it detects it, it'll return a true. If it doesn't, it'll return a false. Right, so it says true. What if I put in FL? Returns a false. Right. So where this becomes important is if you get in your data and you want to try to create a new categorical variable based on what you have existing, and you're not doing things like splitting out by date or grouping it by some numerical value. You've got text, right, that you want to use. You can use this str detect, str remove to either clean up your data, right, and create a new categorical section, or you can use things like str detect to detect whether or not, right, that value exists in that string. And we don't have it just for str detect and str remove. There's literally 1,000 of these things. You can look up str underscore see stringer str detect, do equal, escape, extract, length, locate, match. There are all different kinds of text manipulation functions that you can use within Stringer, right? That can help you manipulate the data that's in your data frame to come up with something meaningful or to extract meaningful information out of your data, right?
So you could use that like str underscore detect in a filters statement, just show if. Cause it's gonna come back and give you that result.
So another good one is STR, is it squish? STR squish. What STR squish does is it removes all the spaces inside of a string. So if you do STR tech, there's a squish. Let's say I have E, right? So I got a bunch of spaces in between these letters. I was gonna do that.
Yeah.
That didn't do what I wanted to. What happened? Ow, I must be right, sorry, got that one mixed up. There it is, sorry about that. What you'll often have in your data is that you may have leading or trailing spaces, right, for values. And it may not necessarily even be consistent throughout the data, just may show up as an error at the import. And you want to remove those spaces in the beginning, in the front of the end. You can use STR squish to help pull those out. You can even feed it other kind of more sophisticated patterns, so STR detect. Let's do maybe let's do CD.
So squish.
Yeah, squish is gonna remove the white spaces, right, from the inside. Let's see, there's some examples we have in here. Detect, which, replace, split, sub, so subs, you subset your stuff out. Remove, so you can remove erroneous stuff, trim, right, move kind of trailing stuff. Squish also removes those internal white spaces. It's a whole kind of list of things you can do with those texts. So this is also one area where you're not just doing a lot of Google searching. So you have like text causing an error. How can I use tidyverse to help clean up some of that stuff, right? You're gonna be using the stringer package, some of these functions. Reading and writing text files. So hint, for homework, hints. So we know how to read in data using read CSV, right? And write CSV, we can read and write files using those. But what if we just have regular text, right? It's not in a particular format, it's just a plain text file. It's like a chapter out of a book or something like that. We just have as a text file that we want to analyze. You can use the read lines, right, to read that data in, right? And it'll read, so for each line in that text file, right, it'll read it as a unique line in your data. And you can also use write lines. And write lines will do the opposite, so write the data out. And the last few minutes, let's just touch on loops real quick. Where you guys gonna get your minds blown? I told you we're gonna hit you with a fire hose today. So loops, as the name would suggest, allow us to do repetitive operations, repetitive tasks over and over and over again. So if you want to think about loading data files, or you're trying to do things right that would require you to manually copy and paste your code over and over again, right? But they're all share like kind of a common feature, like you're changing things based off of the, let's say you have like a data set with 10 columns, right, 10 variables, and you want to convert all those from, let's say, in thousands to a million, so you want to divide by 1,000 on all of them, right? So instead of having to type every single one of them out one by one, you can do things with loops. So a loop in general will have start with a for, right? You'll have an index, right? You can call it really anything you want, could be I, could be X, could be Y, something that is unique. In, right? And then something that is a list, right? So you wanna think about, say, X is equal to 1 to 10, right? So X is gonna be a list of numbers from 1 to 10. And I want to loop over X, right? And let's say for each element of X, I want to square it. So I start off with 4I in X. I have an open bracket. I have my operation in the middle here. And I close out with a closed bracket. If I run that, it does something. But it didn't print it out. Nice thing about for loops is I can add another line. So what do we do here? 4I in X. Made X equal to I from 1 to, I'm sorry, I squared, and we printed out X. Right. So the list of X, so I is just gonna be from 1 to 10. And I want X to now be equal to I squared. And then we printed out X.
Mine is saying an error in the symbol.
Yeah, mine's is too.
An error in the symbol?
Did you use the little caret key, so shift 6?
No.
Let's see.
I just had to-
Oh. We use the bracket.
Oh, it's a bracket.
Yeah. There you go. Right. Yep. Bracket. Curly brace, yeah, curly brace, sorry, curly brace.
I did that one.
Sorry,
I did a curly braid.
did a curly brace?
Yeah,
Let's see.
I don't know if I did it right. Maybe I'm missing something.
Oh, put an enter. So put an enter after the curly brace,
I did the first
Yep.
curly.
and then put an enter after before the print. Yeah, and let's put a little enter after the,
Oh.
that's fine, yeah, you got it, yeah.
So it has to be formatted this way or?
Yep,
Oh.
that's right. Good question. But what happened to X? Right? So here, I'm updating X with whatever value is in I squared. So if I were to just type in X at the bottom here, it's no longer 1 to 10. It's now just the last value that we had in there when we looped through. Granted, you got it?
No, I did.
You don't?
No.
See, look, make sure you got it.
You got it?
I didn't do.
I'm supposed to admire.
Jemai, you got it?
Do X.
Yeah, I got it
No, in line 180, sorry, in line 101. So start off with X signs I squared. And then print X.
So what is this
I-
doing?
So what this is doing, right? So if you start off with X, 1 to 10, for I in X, right? So for each element of X, So I is gonna take, for the first pass through, I will be equal to 1. The next pass through, I will equal to 2. The next pass through, I equal to 3, 4, 5, 6, 7, 8, 9, 10, right? And each time, it's going to square itself, and it's gonna save that value back to X. And then we're gonna print out X, all right? So I'm gonna get, this is my output here.
Oh, this is just squared number.
Yep, that's just square, all we're doing is just squaring the number, it's all good.
Oh.
Yep.
See, so.
Right.
There's something about that, so I don't like to change the index. Where Brian is operating on the index,
Well, I'm using this to illustrate an example.
which confuses the heck out of me.
Exactly. So there's a couple of problems here. One is, right, we're operating off of the index, right? So that can be confusing. And then two, we're changing the value of X, here, right? So when I go back out and I just type in X, I've now permanently changed, right, the value, right, that I had for X. It actually was originally 1 to
No,
10.
it's even, so what's bothering me
Mhm.
is that I is in X, and I wrote that at the beginning, and X is changing as I go through.
That's right.
That's what gives me pause,
Yep.
but it's valid.
It's valid, it runs, right? But it's destructive and it's confusing, right?
Yeah.
So
So.
Yeah.
It's like double negatives.
it is kind of like double negatives. So as a practice, right, to avoid all that, what you want to do is this. This solves your problem.
Okay. That's the same thing as.
It's gonna run the exact same thing. No, it's not.
No, because X is not a list.
There we go. I didn't run the line before. Every simple line. So in here, now we're going for each element of X, right? So instead of I being set to 1 to 10, right? I is now set to each position of X. And at each position of X, I want the value of X. I'm sorry, at each position I of X, I want to square it.
Why that squiggly parentheses, what does that mean?
Sorry?
Why did
So
you?
it, so what sequence along does, right, is it takes the object X, right? It says how big is it? It goes from 1 to some number, right? I want I, right, to increment starting from 1 until the full length of that sequence, right? And take on that value. So I is equal to 1, I is equal to 2, I is equal to 3, 4, 5, so on and so forth.
Print out your X to begin. So that they see what X is. See, X is a list.
X is a list.
So what is the importance of this?
So the importance of this is if you have a calculation you're trying to run, right? That requires you to have the previous value as part of it, right? You need to be able to way to index, you need to be able to way to reference the previous value in your data. Or if you have a task that is very repetitive, right? That you want to take out all that copy and pasting they're gonna do in your R script and just wanna have a simple loop, you can just quickly and easily loop over your values. These are things that you're typically not going to run into very often as you're doing R coding. They're not things you're really gonna run into a whole lot in your project. The nice thing about Tidyverse is that it does a lot of this stuff on the inside. Remember we did group by, right? Group by is basically looping over, right? whatever it is you're trying to group. But there are situations where you might not be able to use tidyverse. They are rare, but there are cases where you might not be able to use tidyverse to do those looping things for you. And you may need to have, use a for loop to do that. And that's where they come up.
My numbers are just showing 121.
Oh. I said I was exit, you do 1 to 10.
I'm okay with that. Does that make sense now? So, I'm trying to think of some numerical analysis type of stuff. Compounding interest, things like that.
Factorials.
Yeah,
Yeah.
but nothing jumps out at me off.
Yeah. So again, as I started off the lecture, it's kind of like a cornucopia or a shepherd's pie of things. There's a reason why this is at the very end. This is why we're not dedicating a whole lot of time to it. And it's okay if you're a little confused,
Yeah.
kind of looking at it, and that's understandable. We will have office hours to help you guys through some of this stuff. Again, in the past, like this used to be a bigger part of the course, but Mark and I think we kind of have gone through it. I think you and I have only seen this once. And it was a very rare, it was a very extreme example. You're typically not gonna run into this. Again, let's say you have a bunch of data files that you need to import, right? Instead of doing them one by one, you could use a loop, right? To loop over the files that are in a directory, load them in, right? Append them to like a data frame, right? And then save things out as one large file. Right, that's really where I think, when I use loops like this, 9 times out of 10, it's because I got a ton of data that like I gotta feed into a model somehow, and all the files are separated. So I can just read the files that are in a directory, right? And then just loop over each one, load it all in. And that's really, we got through it.
Yeah, it's a lot.
That, dude, I'm serious, that was an incredible lot. I tried to be mindful of that on this week's homework. I've put a little bit of stuff in there with some strings. I've tried to keep it light. I've given you some opportunities for extra credit. So if you really want to go out there and go nuts, you can. But this one should be pretty, what we've done today with strings should get you through. We've got a thing in there for loops. What we've done here today with loops should get you through. The bulk of it is going to be on graph, doing plots, as we did today. Right.
So working with strings and coding in strings is like the worst thing about code.
Yeah. Like functions know how to deal with numbers very well. We've got almost 70 years of code written to handle how to add, subtract, multiply, and divide. Strings can take on any value, and it's not exactly, and they're all context dependent, right? And so it can be very, very painful dealing with these things, and these types of helper functions take the sting out a little bit, right? Whether it's you got data that you want to extract, whether it's data that you need to turn into something else, right? And you can't easily deal with it using an if-else statement or a case when, or, right? You're gonna need to do something a little bit more fancy, and this is where these things are. And as always, we will have this saved out to, we'll save the script out, right? So you guys can have it. I'll clean up here a little bit, be a little more descriptive. We did a lot of little ad hoc stuff here. And then we'll have the lectures saved out to YouTube shortly.
Yeah.
I don't know, Mark, if you have any other announcements, so.
Just stop the recording. That,